Welcome back to our live training session here with our Honda EP3 Civic. Now this training module, we're going to learn how to calibrate our VTEC activation as well as our high cam volumetric efficiency, spark timing, and variable cam control. Now we've mapped out in the last training module in pretty painstaking detail all of the things that are going to be making sure that the low cam was properly dialed in. So low cam is VTEC off, high cam is with VTEC on. So we have our fuel, our VE airflow models dialed in, we have our spark timing, we have our knock control centered around the engine and set up properly so that if it does start to get knock, it starts to retard the timing. We saw that in that last training module. And the variable cam control was optimized to give us the broadest torque curve possible on low cam. Now when we're gauging VTEC, things are going to completely change. VTEC is going to have a different lift and duration on the camshaft profile and acting almost as a different engine. So we want to figure out what the proper fueling is going to be, the proper spark timing, and the variable cam control when VTEC actually is activated. Now this is going to be a little bit of a problem with Motec in the sense that we don't have two volumetric efficiency tables and two spark timing tables and two variable cam target tables within the programming here. We have to make everything work within one table, which is definitely a disadvantage compared to other systems like Mtron or Link or Haltech that give you a lot of flexibility to have different table switching. If we have a different cam profile, obviously we're going to have different cylinder filling. We'd like to have a table dedicated for low cam and a table dedicated for high cam. Same with spark timing. We're typically going to run a couple more degrees advance from low cam to high cam on our K-Series engine. And our variable cam target definitely changes going on the high cam profile. So we need to make this all work on one table. Now it's not impossible to do this, but it's definitely not going to be the most ideal way to handle things. How do we go about setting this up? Well, first thing we have to do is go in and engage our VTEC really low. We're going to engage VTEC at something like 2,500, 3,000 RPM. And then we're going to go ahead and do a pull and figure out where we're at in terms of our volumetric efficiency table, in terms of our spark timing, and in terms of our variable cam control. But we do need to set some things up. First thing I want to do here is jump into my inlet cam table here. This is my target table that I found worked on low cam. This is our cam composite blend that gave us the broadest torque curve and torque band on this particular engine. I'm going to go here from 80 kPa and above and zero this out. So I'm going to grab my values in here and I'm going to zero it out because we want to go in and reestablish this for high cam when VTEC activates. So we kind of have to go through a little bit of that same process we did in the last training module, and we can always put it back to the previous values. In fact, we're going to find that once we get up to something like 3,000 to 4,000, where VTEC typically engages, we're going to find that the values are probably going to be the same all throughout the rest of the table. So we'll learn how to deal with that and the blending that we have to have within the table using just a singular variable cam table. Let's go ahead and store that. Ignition tuning, we find that we had our optimized timing at 21 degrees. This will be a safe starting value because it worked on low cam. It'll definitely work on high cam, but we might further be able to refine and optimize this. Now when we engage VTEC, obviously we're going to have to share the same timing table with VTEC activated with this firmware package. We don't have the ability to have two different tables that we can run two different spark timing profiles for the low and high cam operation. Same with VE. So the VE table here is going to have to be essentially at our higher engine load. Let's say 80 kPa and above, maybe even 70 kPa and above. We're going to go in and have to completely redo the upper area of the table here to suit high cam activation. We have to be careful with the way we engage VTEC. We don't want to engage too low of a manifold pressure and too low of a throttle angle. That'll start to decrease the drivability out of our engine, but it also will be really hard to try to dial things in because you're not going to have a clear line of where the engine's on low and high cam within this VE table. Kind of want to have to draw some of the parameters, draw a line, so to speak, within the table. So we're going to say here 70 kPa and below, VTEC's off. 80 kPa above, VTEC could be on or could be off depending on the load and the throttle angle. So let's look at this real quick. Let's go through and just set some of the parameters and variables up for the VTEC control so that we have this defined properly. I'm going to say anything below 70 kPa, VTEC off, anything above 80 kPa and higher, VTEC on. We want to be on our throttle and be under load really to engage our VTEC. We don't want it in part throttle that can give us some drivability loss. Let's go here to our setup and we're going to jump into all calibrate. And in here, we're going to use our aux output, and we have our aux output to assign for VTEC control using a half bridge output. We're going to go here to our duty cycle table, and we're going to go and expand this and talk about this real quick. This table is set up based on throttle position and based on engine speed. we're going to engage our VTEC from 3,000 RPM and above for right now, just to get things calibrated and get things set up. And we're going to be really focusing on just our full throttle VTEC operation and calibration process here. So I'm going to say from 50% throttle and higher, and from 3,000 RPM and above, we're going to set our values here to -100. -100 in a half bridge output sends a 12 volt out of our Motec to control the device. Now the VTEC solenoid is going to pull less than an amp, so we can directly drive it using a half bridge output. We're safe on that amp sync between the Motec and the VTEC solenoid. But this is going to be how we engage our VTEC. Now we'll further refine this as we go through the training module and figuring out the exact VTEC point and talking about how to deal with our breakpoint axes around that specific engagement point. We also want to take a look at our active thresholds here and set our inlet manifold pressure minimum to be something like 70 kPa or 75 kPa. That'll allow us to say we have to be at this much manifold pressure and then meet this throttle angle and this engine speed for VTEC to engage. This ensures that we have a clear kind of defined line in our volumetric efficiency table that we know low cam is going to be active below this certain manifold pressure, and then high cam will be active above this certain manifold pressure as long as we're going in and meeting these conditions. Okay, here, that should be good to get things going to do our initial calibration. And we're gonna just do our baseline pull here on the main line and just feel this out. So variable cam timing is 0 degrees.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.